In the last video, we looked at one-to-one functions, and we looked at some examples of how to figure out if a function is one-to-one or not. Now, if we have the graph of a function, then this test, called the horizontal line test, gives us a quick way to figure out if a function is one-to-one or not. So, the test says that if every horizontal line intersects the graph of a function f and at most one point, then the function is one-to-one. Now, another way to look at this is if any horizontal line intersects the graph more than once, then it's not one-to-one. That's usually a better way to think about it. So, for example, in this first example here, for this graph, if I can figure out a way to draw a horizontal line to cut the graph more than once, then it won't be one-to-one. And of course I can figure out how to do that. For example, this line cuts the graph in more than one point. It happens to be 3 points. And so for this reason, the horizontal line test says that this function is not one-to-one. And similarly, for this next example here, if I can figure out a way to draw a horizontal line to intersect it more than once, which it does here, then I don't have to look anywhere else. This represents basically two numbers that have the same output, two different inputs that have the same output. Now let's look at two more examples here, this one here. So I want to think of a way to draw a horizontal line that intersects this graph more than once, and I can't. If I draw one here, then this has one intersection point. Okay, so I'll try another one. If I draw it here, then this point, again, this line has one intersection point. So there's no way you could draw a line, horizontal line, that would intersect this more than once. Okay, so every horizontal line will intersect this graph at most once. So this function f is one-to-one. In this next example, again, I could draw a line like this and show that it intersects the graph twice, more than once, and so again here f is not one-to-one. Okay? So if you have the graph, the horizontal line test gives you a really easy way to figure out if the function is one-to-one or not. Okay? Now, if your function is one-to-one, then what we'd like to learn is how to figure out the inverse function. So now we're going to talk about inverse functions. Now, if the function is given as a graph, find the inverse, and here the function is given as a map. So here's the map. So let's say the letter A, the letter B, and the letter C. And then here we have the numbers 0, 13, and 22. So here the relation is A goes to 0, B goes to 13, and C goes to 22. And this is the function f. Now to figure out the inverse function, we first want to identify the set of inputs, so that's the domain and that's the range. And what the inverse function is going to do, so here we'll say inverse function, and we'll label it as f with a little -1 on top. That's not an exponent, that's just instead of using the word inverse, we can just write f with a little -1 on top. So that's f inverse. So the first thing you want to do to figure out the inverse is you swap the domain and range. So what used to be the range is now the domain. So the domain now is the numbers 0, 13, and 22. And then what used to be the domain now is the range. So you switch the places, okay? So now the range is what used to be the domain, which is the letters A, B, C. And so 0 goes to A, 13 goes to B, and 22 goes to C. So it's very easy to figure out the inverse if you know the map of the function. And what if the function is given as a set of ordered pairs? So find the inverse. Now let me make a comment here. Look at the original function. The original function is one-to-one. If it wasn't one-to-one, we couldn't go backwards. Okay? So before you think about a function having an inverse, you have to make sure it's one-to-one, otherwise you can't find the inverse. But the examples we're looking at will be one-to-one, otherwise I want to ask you to find an inverse. So let's take a look at this example where the function is given f as a set of ordered pairs. So -3, 3, -2, 2, -1, 1, 0, 0, and 1, -1. We looked at this earlier and we said it was one-to-one. So the inverse function, let's write it here, the inverse function So again, we're going to switch the inputs and the outputs. That's what that does. And so switching the inputs and outputs is essentially switching the x and the y. So the first ordered pair leads to 3, -3. Okay, what used to be an input of -3 now is the output. And what used to be the output of 3 now is the input. So for the next one, it'll be 2, -2. And the next one will be 1, -1. 0, 0 never changes. And then -1, 1. So that's the inverse. You're switching the inputs and the outputs.